Our objective is to analyze how atypical factors, in conjunction with typical factors, better approximate changes in housing prices. Typical real estate people determine houses' prices with factors such as number of bedrooms, number of bathrooms, square feet, year built, schools, zip code. However, we use atypical factors in conjunction with typical factors to determine real estate pricing because people may value how far locations of interest are to their homes. These locations we consider are grocery store, specialty grocery stores such as Trader Joe's and Whole Foods, parks and nature, fast food, gas, Starbucks, and movie theaters. Started off with city selection. We started off with Mount Pleasant, South Carolina. They're one of the fastest growing small cities with reasonable development and large land size. This project was very data intensive. We couldn't do it by hand, so we built Selenium and Beautiful Soup web scraping algorithms in order to get our atypical factors. We wrote to a CSV and geocoded coordinates of the addresses of these locations with Google Cloud's add-on tool. We used typical factors in conjunction with atypical factors, so we gathered data of typical factors such as bed, bath, square foot, price, etc. from Zillow.com using a web driver, and we wrote it to a CSV.
After we collect all the houses data, we must pre-process them before putting it into our ML algorithm. First, we drop the houses with no available data, then drop duplicate houses. Drop the houses with outdated transaction history, which is before 2015. And we also identified houses whose price were recently influenced by COVID-19 and had a price cut because of that. Also, we dropped statistical outliers in terms of house price appreciation, and then we used the remaining houses to put into our ML algorithm. Now, talking about typical factors scoring algorithm, we used the Zestimate, which is for typical factors, and calculated the compounded annual growth rate from 2015 to 2020 using those estimates. And we compared these estimates growth to the actual compounded annualized growth rate in the specific city from 2015 to 2020. After that, we calculated the z-score and assigned scores from 1 to 10 based on the resulting z-scores. So now, how do we score atypical factors? So we converted the addresses to geographical coordinate systems using geocode, which is a Google Cloud add-on. And we computed the distance from each house to each atypical factor and assigned a value of scores between 1 to 10, depending on the distance and the number of each atypical factors within the level of proximity.
Next, model training using machine learning. Using scikit-learn, we trained a multivariable linear regression model with scores from atypical and typical factors for each house as variables. The trained model would return rates for each atypical factors and the typical factors. And finally, model testing and improvement. Our trained machine learning model initially gave us about 55% accuracy. In order to improve the accuracy, we made a variety of different adjustments. First, we attempted to manually change the scoring function for atypical factors. This increased the accuracy by less than 10%. Then we recalculated the CAGR for houses with substantial recent price cuts, perhaps due to COVID-19, in order to accurately reflect the property's value. Then we removed statistical outliers from the dataset. This improved our accuracy by the biggest amount. Next, we automated scoring guidelines and distances by testing 5,000 iterations of random sampling to approach set of optimal distances for scoring. And then we retested 10,000 times, and it gave us average accuracy of 94% for Mount Pleasant. This is the snippet of the code that predicts the monthly price change for a house and returns an accuracy of our model. For Mount Pleasant, it can be interpreted that proximity and number of grocery stores had highest correlation with house price appreciation rate, while typical factors had moderate correlation, and fast food had the lowest correlation on the price growth. What's next? We already started our machine learning model for Seattle, but we are working on obtaining more atypical factors, and right now we are currently on 91% accuracy on average. We expect the accuracy to go up as we better pre-process the data and gather more atypical factors that might influence the house price. We discovered significance of different cities having unique optimal distances and scoring. This shows atypical factors clearly affect real estate pricing. We will utilize more machine learning algorithm besides linear regression in the future. Our ultimate goal is to find trends for cities with similar characteristics and